Good afternoon to all the participants, and thank you for joining us today. I'm Aditya Sharma from E2E Cloud's marketing team. E2E Cloud is an Indian-based accelerated cloud computing platform for all your computing needs. We hope you will enjoy this session and learn a lot from it. Today with us, we have Mr. Ramdas, the Managing Director of Netzary Infodynamics. What Mr. Ramdas is going to talk today is about the problems that many developers face while deploying Kubernetes with the pros and cons of using managed Kubernetes. Mr. Ramdas will talk about common challenges faced while deploying Kubernetes and how to tackle those challenges. You can write your question in the chat box, and Mr. Ramdas will answer those questions during the webinar. Mr. Over to you, sir.
Okay, thank you very much. Can I be made the host so that I can launch?
I've made you the host, sir.
Okay. We are going to speak specifically about Kubernetes, and we will be covering certain topics, which is what is Kubernetes, why Kubernetes, what workloads fit Kubernetes, what kind of apps suit deployment in Kubernetes, and a readiness test for your infrastructure, whether that infrastructure is good enough to be migrated to Kubernetes, and where you should not use Kubernetes. It's also important, and how much it costs, what all you need to prepare as you move to Kubernetes, what pitfalls and mistakes you need to avoid in this journey, what should be your end goals, some security practices, and finally, what are the advantages of E2E's Kubernetes platform? So this is broadly what we are trying to cover. What is beyond the scope of this talk, that also let me make it clear. We are not going to show a demo. This is not a hardcore technical talk. This is more from decision making, more from looking at looking at aspects of Kubernetes which requires a granular attention. Then we are not going in depth inside DevOps also. Okay, what is Kubernetes? This is a definition which is there, which I've directly picked up from the Kubernetes website. Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. So the most important thing is that it's open source, and it's governed by a committee which is outside the original promoters, which is Google. Google open sourced this about 8 years back, and today it's a $1.7 billion USD market for services and expected to be 5.7 billion USD. Now, this is just a services market. There is a ancillary market which is associated where there are a number of vendors, right from the storage and server vendors, selling to this market. That is a fairly large number. We do not have any precise data, but it's estimated again to be in excess of $10 billion plus. One of the key research points which has come from Sogeti research is that with Kubernetes, server CPU utilization improves from 25% on average to 75% for classic VMs. This is a very important point, and this would be repeated multiple times during this talk, because that's how where Kubernetes is going to save you money. Now, this is how platforms have emerged over the past 2 decades, since 2000 or 2002. Those days we used to have app servers where everything used to run in a bare metal server, where you could have multiple applications, but all it had was the operating system and the applications. Now, I can give you a classic example is the Karnataka State Education ran a server where there was no utilization for 364 days, just only on the day of the SSLC exam, when the results were put up, that server was getting accessed. And every time they had to increase the number of servers and then shut them down after some time. Now, that's how it was. It was very difficult for, the machines used to crash, and it was, difficult for at that time, there were no management tools for us like what we have today to kind of manage the infrastructure. But from there, since 2006, we have seen virtualization coming in slowly. So virtualization, again, the same hardware where the CPU utilization was at 4 or 5% or up to 15%, 99.99% time, you could actually split that up into multiple VMs and then increase the CPU utilization. Then now what we have is containerization, where you have multiple running on the same virtual machine or on the same bare metal server, and you could manage more containers in a particular hardware infrastructure than what you would have, if you were following any of the previous architecture. This is again, in the last 20 years, you've seen average CPU performance grow, tremendously. I mean, Moore's law hit that the spot in 2002, and from there, in the last 20 years, Intel and AMD have been adding more number of cores. I mean, the latest AMD machine, AMD processor, EPIC 9000 series has 192 threads or 96 cores. And over the past 20 years, 15 new generations of processors have evolved in server platform alone. RAM hasn't seen that kind of growth, but then again, you've seen clock speed clocking up by about 20 times. And 5 new standards have also emerged from DDR1 to DDR5. Drives have seen tremendous performance improvement. The fastest drive in 2002 used to give about 180 IOPS. Today, data center drives, the best data center drives gives you around 300K IOPS. There are drives which are giving about 1 million IOPS plus, but they're probably not commercial grade enough to be deployed in large quantity in data centers. Networks again has seen huge improvement. I mean, we have 400 Gbps commercial grade, networks being backbone of data centers. Now, the most important thing what we need to remember is that the processor is still much more faster than the RAM, the hard disk drive, and network has seen tremendous improvement again. So from the perspective of compute platforms, we have to look at methods, processes, and frameworks where you are using the CPU utilization has to be better. So that's one of the key goals which where computing is, which is a direction which computing is taking in the current decade. And so we established, and containerization helps that, because in the same virtual machine you can literally run hundreds of containers, which instead of running a few applications, you can actually increase the utilization much more better. Now, why Kubernetes? So this is the current and standard approach which we usually see in most places where we are using virtual machines or bare metal servers. You have a CDN which usually sits outside the infrastructure. You have a load balancer to which the web requests come in, and which gets split to multiple web servers. Then you have caching, you have database, you have queuing, and then you have workers, The database servers could be multiple servers in master slave and various configuration. Similarly, you have queue clusters, which could be Kafka, ActiveMQ, RabbitMQ. You may have in-memory databases like Redis for caching. You may have something like an Elasticsearch, but all of these things will be running on virtual machines with very specific purpose. And now one of the challenges what we have is that we do all the planning specifically for the infrastructure, but either we will have to overplan basically for the spikes. For a spike which might happen for like a day in a year, we still need to keep an infrastructure which is for at least, even if it is not throughout the year, at least for several weeks, which needs to take care of the spike. And sometimes what happens, the spikes are very unpredictable. You may get a truckload of traffic because somebody referred or a popular blog wrote something nice about you, and you are getting a truckload of traffic to your website or your web application, and that might crash that web application. You may have certain periods which is probably more predictable, like the accounting, the audit period. Then yes, that particular time a fintech application is going to see more users coming in. Despite all the planning what we are able to do, the current and standard approach doesn't give you a 99.99% uptime. Despite data centers and the cloud providers promising you that, I mean, they do provide you infra which actually runs pretty well, which actually offers between 99.99 and 99.99% kind of an uptime, which is less than a few hours, a few minutes in a year, kind of an uptime. We're still not able to reach there. One of the primary reason is that you cannot plan your infra the way you want to, despite you putting up clusters in ensuring that every possible redundancy is kind of established. You still are not able to achieve that. Now, how does Kubernetes help, or how does Kubernetes change things for you? First, let's look at if we are running things on a bare metal server. In a bare metal server, you had a downtime, then it takes, depending on the component which is failed, it takes anything from 20 minutes to probably 2 days to replace that component. And if the application is on an infrastructure which is purely based on bare metal, that's the kind of downtime it is likely to suffer, unless you have planned redundancy. And redundancy in this case means another server, which means your cost is, your colocation costs are much, much higher. In case of a virtual machine, if a hardware fails, it probably takes much lesser time to spin it off from another virtual machine, another server. But I would imagine that would be probably between 5 minutes to 10 minutes, depending on the size of the virtual machine and the kind of planning you have done in terms of keeping machines on machines ready for failover. In case of a container, you can spin up a container in a matter of few seconds. And if you are able to automate that entire process, then that is an extremely good win-win situation for you. And that's exactly what, with Kubernetes, we are trying to achieve. This is a very standard diagram of Kubernetes architecture, which is something which is there in, on the Kubernetes website. You have fundamentally two elements in Kubernetes. One is the master node and the worker nodes. Master node is something which I'm not going to go in depth in this conversation, because unless you're going to set up Kubernetes yourself completely from scratch on either VMs or bare metal servers yourself, you really need not know anything much about master nodes, because a cloud provider like E2E or Amazon or Azure takes care of managing the master node for you as part of their Kubernetes services. The what we need to worry about is basically the worker node, because it's the worker node in which all your infra, what you saw in the previous this thing, which this entire infrastructure is going to run on multiple worker nodes, and that's the approach what Kubernetes takes. This is a diagram of Kubernetes components. You have an API server, cloud control manager. This is what exactly is there in the master node. Again, these are fairly complicated stuff. As a user of Kubernetes, or as a developer, or even as in an implementation person, as a tech person, you need not know anything about these things at this point of time, or maybe even in future also, unless you're going to set up Kubernetes yourself. And that's not something which we are going to discuss in this talk. Now, this is basically the components. These are the components which are there in a worker node. Yes, so here what is most important is kubelet. Kubelet is basically the agent which Kubernetes runs inside each worker node, which talks to the Kubernetes master and then performs various functions it's supposed to take care. You have a container runtime, and you have the network proxy. Then you have the concept called pod. What is pod? Pod is basically the Kubernetes unit which takes care of where you will have one or more containers running. An example which you can think of as maybe a Postgres SQL server. So you have the basic server, you have the various services which is associated with Postgres, can then run in multiple containers, and that can be a pod. And you can have multiple pods of the same service or of different services, depending on the resources you require. I would imagine that, okay, if you're running, you want to ensure redundancy for a database server where there is reasonable amount of traffic coming in, reasonable amount of resources required. You will be running the same pod across multiple machines to ensure that one, redundancy is assured. Second is that in case of failover, you have enough pods to handle the compute needs. This is basically a better diagram which tells you about pod. The pod is again the smallest unit of deployment in Kubernetes. So we will look at now the advantages of Kubernetes. One of the biggest advantages is that approach to containers is not something new. I mean, you had Docker before, and you have a multiple number of micro VMs which are available. Multiple other container solutions are available there in the market. But one of the biggest advantages of Kubernetes is that it automatically provisions and fits containers into nodes for the best use of resources. You don't really worry about things like, okay, you will not run a top command in your machine to figure out, okay, there is heavy CPU utilization is happening on this machine, so I'm going to move this, add a few more Docker instances in the other machine, and then do a balancing act to ensure that the traffic is kind of split. So that that's not required with Kubernetes. Kubernetes takes care of the container orchestration. Other thing is Kubernetes load balances and spins up new pods, and if required, new VM instances, depending on the traffic and workloads. And depending on the system resources utilization, it does that. So everything is load balanced. Of course, it's not something which is very straightforward. You still need to write configuration scripts for this thing. But imagine at 3 o'clock, you're suddenly getting a deluge of traffic, or you discover that some server has gone down. You still can sleep peacefully, because if you're planned for the basic redundancy, Kubernetes would actually take care of the starting new pods and moving pods from one machine to the other if it is required, and can take care of the performance. So if you see, microservice architecture is something which every major software development company, every major solution architect is looking at. And Kubernetes makes it very easy for you to actually deploy things, your software on in a microservices based architecture. And from microservices based architecture would automatically mean that you run each of the component as a separate services, or multiple components as a separate services and then they will communicate based on some open standard to ensure that everything functions perfectly. The best way to implement microservices architecture, or one of the best ways is to run them in containers, and with pods you could achieve that. The other important development which has happened in the last, I would imagine, last 5 years is DevOps. DevOps has revolutionized the way software developers are writing code and are deploying it. It has brought in some amount of structure to way software deployment is done, and it has improved software development life cycles tremendously. Again, using Kubernetes, using the containerization technology, it is far more efficient to deploy software and move to proper DevOps standards. Other advantage of Kubernetes is the portability factor. You can literally go multi-cloud, where you could probably have a portion of your workload running in, say, E2E Cloud, and some of the other workers can run in Azure or AWS, depending on the specific region where and based on latency factors, you could actually achieve that. So advantage with the container is that you could move a container from one machine to the other, from one cloud infrastructure to the other, as long as they're all adhering to the same Kubernetes standards. Kubernetes works with all possible container types. It's not just specific to Docker or any of the micro VMs. It practically works with every container technology which is available. So you could run your master nodes on Linux, and your worker nodes can be Windows. It doesn't. And today Microsoft is one of the biggest supporters of Kubernetes. They've invested considerably in Kubernetes as a technology, and have been promoting it also aggressively. You can auto scale faster. In a classic scenario today, auto scaling means you'll have to spin up a virtual machine, and it could take, again, depending on the size of the virtual machine, a new VM getting launched could be anything from 2 minutes to 30 minutes. And these are basically because of that's how the technology is, the network, the size of the VM, the resources you require. Depending on these factors, you're going to take that kind of a time. A container can get launched in a matter of seconds. So even a fairly resourceful container can be spun up in like 15 to 30 seconds on a decent VM. The second advantage is the self-healing infrastructure approach of Kubernetes. A container, a pod which fails, or multiple pods can fail because of various reasons, and that same pod can be spun back again automatically to keep the application live. In case of a VM failing, you have, of course, with some of the instances, what is provided by E2E and some of the other vendors, yes, you can have the VM up and running, but the application may not come up on its own. The application to come up, you probably will have to automate the process of copying the necessary files and ensure that the services get restarted. That's fairly complicated coding. You'll have to consider so many multiple factors before you actually implement it. And we've done that at Netzary, and we have seen how painful to automate multi-clustered VM, especially for failover. With Kubernetes, you can ensure that pods which crash, applications which crash would come up fundamentally because of the self-healing nature of the technology. Now we look at what kind of workloads you should target for Kubernetes. The most important point over here, which is when your infrastructure needs are a little uncertain. You really do not know how many machines needs to be spun up or how much of infrastructure need to be running all the time. If that's the case, then you need to start thinking about Kubernetes. When your traffic spikes are unpredictable, that's again when a good reason for you to consider Kubernetes. If your architecture, software architecture is not monolithic, where nothing will work without the dependencies. Everything has to run out in a very particular manner, and everything is interconnected that it is impossible to decouple. That's what a monolith is. A classic example you can take is like Tally software. It is supposed to run on a single machine in a specific manner with multi-user clients. There can be other examples are classic WordPress instances where a lot of it has been built like a monolith. Though these days WordPress there are enough and more blueprints available on internet where people have even implementing WordPress over Kubernetes, where high availability is required, where you require your application to be run stable and running almost 100%, where you need to introduce DevOps culture. If DevOps as a culture need to be introduced, you must consider Kubernetes as the platform for deployment, platform for running your infra. And where you have daily code change. And that's part of the business need, where application is consistently getting improved. Then containerization technology helps developers to deploy code faster, because the code goes into a container and it gets tested as a container, and then it gets deployed as a container. And you can always roll back the change faster, because all you're doing is that you're going to use your repository to roll back thing, and then you will land back into the last stable version. So if any one of these six criteria are met, then you should consider Kubernetes. Now, what kind of applications fit? Naturally, high traffic websites, e-commerce applications, mission critical business apps, AI, machine learning and big data apps, IoT apps, and apps in the edutech, fintech and utility apps. So I would imagine from a industry vertical, 70 to 80% of the applications do qualify for a makeover and changeover to a Kubernetes platform. The question is, are you ready for Kubernetes? Because this is something which number of our customers come back and ask us the same question. Does it make sense for us to move to Kubernetes? And we follow a simple mantra where we ask some simple questions. And one of them is, do you have presently, are you using a bare minimum of 5 nodes? There are exceptions to the rule. It can, but 5 nodes is a way for us to, figure out, okay, is there seriously, the application is serious enough to run it across multiple machines. That's one way of figuring it out. So the 5-node rule is something which we ask for. So anything above 5 nodes, yes, you must consider, Kubernetes. The other question is your application on legacy software. The problem with legacy software, a lot of legacy software is it's quite a pain and quite a lot of work to migrate that to modern standards. I mean, some code which is written probably according to the best technologies which were available 10 years back, there's a better way to do that today, right? So if it's all on legacy software or your dependency on legacy software is very high, then Kubernetes may not be the solution. Again, there are exceptions to the rule, but mostly this is something what we, one of the questions we ask is that is a legacy software component. The other aspect which is there is, are you doing the basic DevOps rule of keeping code in repositories? If the code is not kept in repositories, then it's very difficult to do a proper CI/CD deployment mode, and it'll not work with Kubernetes. And how much are you depending on a lot of proprietary technology? If there are a lot of components which are proprietary, then and if they are not adhering to open standards, again implementation becomes a big challenge. It's still possible, but then it would involve probably taking support from various vendors and could be a very cumbersome and expensive affair. Then do you see challenges in going the microservices way? Because that's a question which is very important, which you should be able to answer, to say that, okay, is it possible for me at some point of time, may not be immediately, to split your workloads or the way your software is written, and at least a portion of them can be spun off into microservices. Why? Because that's the only way you can spin up multiple containers, multiple pods in this case, and then you can do a better planning, better implementation, and take utilize the infrastructure better. Other thing is, does your code base change very often? If your code base is not changing very often, then we should be looking at better models or alternate models to save costs or to improve performance, improve your uptime than Kubernetes, because there are other ideas which you can implement which would be much more cheaper than a massive change in your approach to infrastructure. What cases you must not consider for Kubernetes when your app size is small? Obviously, you don't want to do any major re-engineering, too much of legacy code. You have challenges in decoupling app into services. Your dependency on proprietary tech is high. and application uptime is not critical. And finally, your application needs are very predictable. If these are, reasons why you should, when you're doing the balancing act of either going for Kubernetes or not, these are questions which you need to find answers, and the answers would automatically, the decision would be made very, very easy once you have answers to the 6 questions on either side. You could add some marks randomly depending on your business needs, and the answer and yes or no is going to emerge very, very easily. Yes. Now, how much does Kubernetes cost? So for running Kubernetes in terms of actual infrastructure costs, the good news is that it's not just E2E. No one really charges a very, very huge premium. There is a premium when you go to major cloud providers. But it's not such a large premium where you need to be really worried, because you already are paying pretty high for services from these vendors. So there's going to be a premium over it. But the real cost are these 4 elements. What is people? You need to have either an outsourced DevOps engineering consulting team, or you need to have a DevOps engineer in-house. There's absolutely no way you can move to Kubernetes without having that expertise there. Practices, if you're not doing CI/CD, then there's absolutely no way. I mean, my personal suggestion is that at least you should have a code repository. If you're not deploying code, if you're not using a code repository like Git, then there's no way you can think about Kubernetes. The CI/CD is extremely important. You don't have to use the greatest CI/CD tool, but a bare minimum, someone should be able to use, either a managed CI/CD service, or they should be able to write code in, a free platform like Jenkins. So that practice of, CI/CD is extremely important. Then, for really utilizing Kubernetes and taking advantages of the platform, you have to think about moving at least a portion of your software code base to microservices architecture. You should be able to differentiate, decouple some of the elements, and it can even be simple. I always go back and look at a 3 services rule. Are you able to split your product into, or your service into 3 separate services, and then ensure that could run independently out of multiple machines? Yes, we can start talking Kubernetes. And then some organization may have to change their approach to a fairly open culture where the developers are involved in taking a lot of decision. I don't know whether to put a cost against it, but that's something which has to be considered before you move to Kubernetes, or when you do the costing aspects of Kubernetes. So infra costs, irrespective of which platform you are, it's not going to go up significantly. If your bill is, say, $1,000 on in AWS, it's probably going to go up by 10% or 15% because you're on Kubernetes. If it is on E2E, it doesn't go up even by 1 paisa. So this is a plain facts. And but yes, in terms of how you're going to approach this game, you will have to look at these 4 aspects from a costing perspective. So is it worth the trouble? Absolutely. You will deploy code faster. You will go to market faster. You will give more power to your developers. They will feel empowered that, okay, they are able to do things their way. You will see lesser downtime after the first 30 days, because there is going to be a lot of teething problems. lesser infra costs as you scale, as the number of as the traffic grows, as the compute need grows, you will spend lesser on your cloud bills. And most importantly, you will see better utilization of the infrastructure, because you will see that whichever how many of our virtual machines you are running, the CPU utilization would be better, memory infrastructure utilization will be much better, and you will see things better. Your observability of your platform will be much better, because Kubernetes is basically infra in code. So then what happens that you will have, and you have plenty of tools which are available, which will provide you very deep insights into how you are using the infrastructure. So all these things are absolutely worth the trouble, provided the original 6 points of which I had provided, why you should consider versus why you should not consider. If you are able to do that balancing act correctly, this is a technology which you will want to bet on. Okay, so what all you need to do to prepare as you move to Kubernetes, bare minimum DevOps, you need to have that expertise either in-house or in outsourced. CI/CD, understanding of containers and storage. This is required for your infra team. We'll delve a little in depth about storage in later part of this talk, but these are the 3 very elementary aspects. When I talk of containers, yes, decent knowledge of Docker is good enough. Storage, you don't really need to have a NetApp or EMC certification there, but you need to understand that containers do not have persistent storage, and you should be able to set up a persistent storage either as a service from the cloud provider or by yourself. And that basic knowledge of technologies like, or protocols like NFS is an absolute requirement. Now the next slide, we are looking at what should be your tech team skills. So I have divided into 2. One is a bare minimum skills, which is knowledge of JIT, which is to use anything. It can be GitHub, GitLab, Bitbucket, whichever is the or your own hosted Git repository. They should be able to, they should know at least 10 or 12 commands basically to roll back, commit, branch out. These commands should be known to your team. They should have a decent knowledge of Linux, though with some of the cloud providers, even that is no more a requirement, but I would still say that Linux knowledge is important. Knowledge of Docker is very important. Again, any block storage / NFS, you need to have a decent knowledge of that. Basic networking ideas like TCP/IP, UDP, and YML. YML is very important because most of the tools which you use in all the open source tools, I would imagine, are on use YML extensively. So knowledge of YAML is extremely important if you're if you plan to be on Kubernetes platform. Yes. Now, if you need serious, the serious skills would be knowledge of one of the scripting languages. I added Go there. Go is not a scripting language, it's proper. When Python is not just a scripting language, it's today a very full-fledged development platform, development language. Knowledge of Jinja 2. Jinja 2 is basically a templating language which evolved out of Django, which is a Python-based web framework. That's important for hem templating. Then CI/CD tools like Jenkins. Knowledge of queue management is extremely important because you need a solid system basically for the containers to communicate with each other. Knowledge of Terraforms and or Ansible. In case of if you're planning to deploy, you don't really need to know Terraforms on E2E, but Ansible is good enough. Ansible is again a platform which is extremely popular. Hem, and a decent working knowledge of monitoring tools like Prometheus, Grafana, Kibana. Kibana is a logging tool, and Loki or Loki. Any one of these or a combination of these are very important. Now, one of the questions which has come in is basically, how long do you think you can build this expertise on these technologies? It depends, right? But I would imagine that to start off for what is there on the right side of the presentation, which is basically what are good to be in your armor. I think it would take anything from 3 to 6 months to get really hands-on. I think any engineer, any decent engineer, can actually take themselves to a certain level from scratch, provided they have a basics of Linux and Docker and Git and all. They should be able to get themselves ready in a matter of 3 or 6 months. There are probably end of this thing, I'll also give you some references of the courses what you could do to master Kubernetes. Now, I'll look at some of the pitfalls and the mistakes what we went through. Our Kubernetes journey started about a couple of years back, and we've had we were managing a Kubernetes which was set up. It wasn't a managed Kubernetes, and we went through a lot of pain. We have been using managed Kubernetes of different vendors for different customers of ours, and from whatever we have learned, these are about 5-6 points, which is very, very important. Avoid setting up Kubernetes yourself. This is something that is not worth the pain. Always use a managed Kubernetes setup. Now, I did mention earlier that E2E, there's not a single rupee cost you will incur, basically because you're signing up for Kubernetes through E2E. Whatever is the current infra bill which you're paying for a virtual machine on E2E, it's the same VM cost as what you will end up paying if you're using Kubernetes with E2E. So always you should use a managed Kubernetes setup. It's not worth your time and money to manage or to set up a master node and manage it yourself. When you're getting it done free, right? So that's a first and foremost rule, is never do the mistake of, unless you plan to improve Kubernetes yourself and then build a company which is going to be a Kubernetes vendor, do not do this. The second point is understand shared storage, importance of shared storage in your infrastructure. Time and again, I've seen this mistake being made multiple times, and I myself have made this mistake of trying to run or save things into a container instead of saving data into a shared storage. Always use a shared storage, because none of the containers have persistent storage. The second challenge what you will have is that in pods come up and go down, they crash, they get killed, they are spun up in a matter of seconds. So unless the data stays inside a shared storage, and the shared storage can even be something which is set up on a couple of multiple VMs, or it can be a self storage, or it can be storage provided by enterprise vendor like EMC or NetApp. Does not really matter. You have to ensure that you use shared storage. The other issue is related with security. Very common mistake what people developers do. They really are, they don't think about security so much, so they keep missing out on security configs whenever you deploy applications. Another thing which you need to look at is basically the dependency checks. Okay. Hello.
Yes, sir, you're audible.
No, I believe getting a feedback that the screen is not moving.
No, it is moving, sir.
Okay. Are you able to see the screen that you're able to? I hope you're able to see the screen with security configs and dependencies.
Yes, dependency
Okay,
check. Yes.
great. Thank you. So dependencies is something which is very important. I mean, this is not something which, I mean, it's true for any platform, any software, any process in IT. Dependencies are extremely important, but it's even more important because you're splitting your software into multiple services. So each services will have its own dependencies. So at a container level, at a pod level, you will need to plan, for dependencies absolutely well and ensure that things are tested. The other challenge, I mean, this is also true for, any infrastructure, is basically setting resources limits. In earlier days, one of the challenges which we faced, I'm talking of a decade back, when you used to run all your software in VPS, virtual private servers, you will see certain performance issues fundamentally because one virtual VPS, which would be run by some other person, another thing, would actually take all the system resources. And then your application is going to run very slow when you're getting only 10 visitors to your application. So same applies here. Of course, with containers, you can manage things better, but you need to ensure that you set various resource limits, like, okay, the number of processes which need to be running on a particular container per particular pod, and the the RAM utilization, CPU utilization. You have to ensure that these settings are done. Set and rest of the things Kubernetes will then automatically take care of. Similarly, you should plan for pod disruption budget. You have to also ensure that whatever happens, a bare minimum number of pods which is required to ensure that your final service is rendering correctly. You need to basically plan for that. Common mistake which some of the our customers have done is they have not planned for it, and then they end up crashing their application. So these are two very elementary but extremely important pitfalls which most of us have fallen into in the past. And I want to ensure that people who are getting onto Kubernetes platforms do think about this, that this is a potential issue which they may be. Okay, so here is a very shameless plug. If Kubernetes isn't your business, please outsource running Kubernetes to a team for whom it is a business. I mean, the reason is that most of the time when someone is planning to, and at this juncture, let me make it very clear. This is not about even running a managed Kubernetes, utilizing a managed Kubernetes service. The basic move, migration to deployment to taking it live to testing, you need someone who does Kubernetes 24/7. Rather than hiring a team of DevOps engineers and migration specialists, you may want to outsource this. And we are there always. And so this is a plug which I have to offer before we move ahead. The other point which is there is in Docker containers, you should never use the latest tag, and you should always specify the version, because Docker gets updated again very often, and you may not update that application that often, and then this could when new pods are getting spun up, things may not work the way you thought it would. Also, you should have a strong testing plan in place, because with deployment happening very, very frequently, and that's one of the reasons why you are moving on to Kubernetes. Application testing and having a strong testing plan is very, very important. Now, there are 3 best practices which I kind of recommend. These are not exactly practices, but one of the very important point here is that you should not expect immediate results, because this is there is going to be some amount of learning curve for your entire team, and optimization takes time. It could take a month. It could take several weeks. It might take several months, but always be assured that the end result is going to be good. But don't get frustrated because, oh, I moved on to Kubernetes, my bills did not come down that much. But, my application uptime and is still the same, or we are facing this issue, that issue. Those are issues which are going to continue. And always keep a separate test and dev cluster. That can even be a fraction of your real infra, but it's very important to keep deploying first to a test and dev cluster, testing it, and then deploy your code to your production environment. It is true even for any platform, but it is even more for Kubernetes because this is heavily developer powered approach rather than an infra specialist approach. Okay, this is a final slide. Now, why E2E? So we are a cloud agnostic company. We have customers who run their cloud applications across probably all major cloud providers, and these are very important points, which I have to mention, because we do recommend E2E as the first choice to most customers. And I keep doing that, and one of the reason is that the biggest challenge is master nodes. E2E provides such as a service by themselves. We don't have to really worry about master nodes. So that's also true for, I think, all the major cloud providers. The other challenge, other reason is that, okay, you get very personalized support. You can even talk to the E2E team in Hindi and Tamil and all local languages. And overall, you can be assured, if I compare with AWS, you will be at about 60% or lesser of the cost. And I'm sure compared to AWS or GCP, it's more or less going to be in a very similar range. And most importantly, there are no hidden costs. The biggest surprise, which some of our customers come back and tell, that we do project a particular billing at per month for our customers, but they end up paying more with other providers. And with E2E, we've never had such scenarios. I mean, I can't really think of any customer coming back and saying that, oh, this was a bill what you had promised, but we got a bill which is much larger. It's, to my best of memory, it has not happened. So these three are extremely important aspects before you consider moving to Kubernetes, and there are good enough reasons to consider E2E. This kind of summarizes my presentation. My email ID, mobile number are available here. I can also share this presentation. We'll upload it to one of our FTP servers and then share it as a link also, which E2E will make it available for all its users. Can we take some questions if there are any questions? Aditya?
No question, sir.
No, I believe somebody has raised a hand. Can you check?
Sure.
Can that question be typed?
Yes, Mr. Arun, you can write your question in the Q&A section.
I'm stopping the share here.
Sure, sir. Mr. Arun, you can use the Q&A section or the chat section to ask your question. I think no questions, sir. So thank you, sir. It was a very insightful session. And thanks to everyone for attending this session. I would like to thank Mr. Ramdas for his time and for sharing his
I think the
thoughts and
question has
knowledge.
come now.
Sure, sir. Go ahead.
Oh, no, it's not. Okay, right. Thank you very much. Yeah.
Yes. So I hope everyone had an excellent time and is leaving with valuable insight. I would like to let you know that E2E Kubernetes as a service is available on E2E Cloud, and you can contact us for your free trial. E2E Cloud will be having another webinar on deploying machine learning model in production on 15th of December. Invites will be sent to all, and we hope to see you all there. Thank you for joining and have a nice day.
Yeah, thank you very much for your time. Anything you can write to ramdas@netzary.com with your comments or questions, or if you want any free consulting, we are there available on Kubernetes. Thank you very much. Bye.